ఒకసారి తలుపులు పెడతాయి ఫ్యాన్ వస్తాను సౌండ్ తలుపులు పెట్టు అంటున్నా. So good afternoon everyone. I'm Anurag Ravirdi and I just wanted to teach you some a topic about ninth class physics. So first, ninth class physics. So ninth physics is part of general science chapter, general science topic. So is part of this general science subject. So in general science, physics has five chapters. So physics has five chapters. In that, first one is motion. The second one is force, force and laws of motion. And third is gravitation. And fourth is about work and energy. And fifth is sound. Fifth chapter is about sound and its properties. So these are the five chapters in physics in ninth class. So first chapter is motion, and we are going to discuss about motion today. So motion in physics, in physical sense, what is motion? Simple. Motion is nothing but movement. So movement of anything in any way. So what is movement? Normal. Take a point, for example, take a point A, and from point A to point B, the distance is 2 km or say 1 kilometer, and someone moved from point A to point B. Then it is called movement. Simple. Something which is whatever it is moving, it is called, it is said to be movement. Something is moving from one point to another point, then it is called movement. That's it. That is the simple definition of movement or motion. So, but in physics, we go deeper than that, and there are different types of motion, mainly three types of motions. So, first is linear motion. So, linear motion is simpler, but it is straight line motion in straight line is called linear motion. Like this, from point A to point B in a straight line for a particular distance. This is called linear motion. Simple. You take any car on road, moves in straight line. That's it. That is the anyone walking on a footpath. Walking on a footpath is or jogging on a footpath, he travels in straight line. That is called linear motion. It is just as simple as that. And then after linear motion we have uh, circular motion or rotational motion or spinning motion. So circular motion has two types. One is rotation and another one is revolution. So rotation and revolution. So when it comes to rotation, we have Earth. Earth has Earth has both rotation and revolution, right? So rotation. How are days of we daily see days and nights. So we see days and nights. What happens? We see that sun sun rises in the east and then sets in the west. Why does that happen? How does that happen? Because of Earth's rotation or revolution, or is sun? It seems like sun is actually moving from east to west, but sun doesn't move. It is the Earth's rotation. Due to Earth's rotation, we have days and nights. Right. So rotation means spinning around itself. Spinning around itself is called rotation. Right. So due to this spin around itself, we have days and nights. And what about revolution? Revolution is around the sun. So moving in a circular fashion, in a circular way around sun is called revolution. Around what? Sun. With sun as the center. That is revolution. So due to revolution, we have seasons. We have changes in seasons due to the motion around circular motion. Actually, it's not circular. It is elliptical motion. Elliptical motion around sun. We have seasons. But we can say it comes under this category circular motion. Right. This is the second type of motion. And then we have last the vibratory motion or oscillatory motion. Or oscillatory. This is simple. The best example is a pendulum. So pendulum moves to and fro, right? So pendulum moves in a curved way like this. It comes, it moves from this leftmost to the rightmost point. This movement is called vibratory or oscillatory motion, right? So this is a simple example. Also, vibratory when if there is a rod or a pole like this, it is if we let's say we hit it with a hammer or something else, and then it vibrates just very very less amount of movement, but it does vibrate. That comes under this vibratory motion. So oscillation means the oscillation of a pendulum, right? So this is the third type of motion. And after this we have a reference point. So what is a reference point? Reference point means nothing but we take a one point as reference and we get to know the location of another point. Let's say this is the point A and this is point B. So reference point. So let's take A as a reference point and we find out the location of B with respect to this point A. So let's say the distance is some 2 meters or 3 meters, something like that. 2 meters is the distance, and the direction is along this direction. That is something like northeast. Northeast is the direction, or and distance is 2 meters with respect to this point A. And if I take another point C here, then let's say the distance is 4 meters and the direction is north. Then with respect to the reference point C, this is the distance. The distance of B is 4 and the direction of B is north with respect to the point C, reference point C. So in case of what linear motion. So in case of linear motion, so in a straight line, what happens? Just we take one point A, and as with respect to A, let's say B moves in a linear motion, which means it either goes far away from A. This is the first case, and it comes nearer to A. Right. In both cases, we are taking A as the reference point. This is the reference point. Right. So in this case, B is moving farther from A, and B is coming. In this case, B is coming nearer to A. Let's say a person is standing on a bus stop. This is a bus stop, and the bus is coming nearer to him. And this person, if I take this person as a reference point, then let's say bus is coming at a speed of 30 km per hour speed. It is coming towards him, and there is another person inside the bus. I'm taking the person inside the bus. With respect to this person outside, this person is also moving at a speed of 30 kilometers towards him, right, with respect to this man. And if I take another person with respect to this second person inside the bus, this person is coming towards this bus at a speed of 30 kilometers, right? You understand? So if it is about taking the reference point, if I take this man as the reference point, according to him, this person outside is coming towards the bus at a speed of 30 km per hour, and with the same reference point as this person, if I take this person, he is at rest with respect to this person. That is the concept of reference point. And in this linear motion, this is how we use reference point. Right. After linear motion, we have rotational motion. So let's take a coin. So in case of rotational motion or spinning motion or circular motion, if I take a coin and I spin the coin on the table. This way, I spin the coin on the table. As it is spinning on the table, let's look at this point from above. From above, we'll look at the coin. If this is the table, from above we are looking, and this is the coin. So this is the coin. So what happens? It rotates. It spins, which means so it moves around its center. So here I will take this center point as the reference point, and I will take this point edge, point as a reference point. I will find out the direction and speed direction and speed of this point, this edge point, with respect to the center. So it moved from here to here, this point to this point it moved, and this will definitely have some speed. This will definitely have some speed and direction. The direction is towards this direction, and the speed will have something like, due to the rotation there will have some angular speed there will be with respect to the center. This is how we can, with respect to the reference point as a center, we will find out the rotational motion of this point at the edge. So in rotational or spinning motion, we mainly consider the angle change in angle or angular distance will take into consideration, right? So if I take if I take a ball if I take a ball and I attached it to a string, and I I spun the I rotated the ball with my hand, with my hand here. I'll rotate the ball like this, like in a circular fashion. What will happen? The ball will move in a circular fashion around my hand, around the center of this circle. My hand will be at the center, and I will be spinning the ball like this in a circular fashion. So center is the reference point, and ball is moving around the circle, around the center, right? Like this, it moves. So here again, same. What happens is, angle of rotation changes from path to path, point to point. The angular distance, angle keeps changing around the center of the circle, where the center of the circle is the reference point, right? This this is how we see the rotational motion, reference point in rotational motion. And when it comes to spinning motion or oscillatory motion, you can take what a pendulum. So in this case also, this pivot point or fulcrum point, this is the fulcrum point, and with respect to this fulcrum or pivot point, we we see the movement or motion, the oscillator motion of the edge of the pendulum, right? But in these both cases, in linear motion, what happens? If I take a reference point, another point will come to it or go away from it. I've taken the example of bus, and a person standing in the bus stop, and bus comes to him or goes away from him in case of linear motion. But here, the distance between the pivot uh, pivot point and the edge of the pendulum is always the same. But what is changing? The angle is what is changing. And here also, in the circular motion also, what is changing? The angle is what is changing always. So these both cases, the reference point, distance between the reference point and the other point we are studying, the distance between them is always the same, but angle is what is changing, right? Okay, next, after reference point, we'll have to define scalar quantity, scalar and vector. So what is a scalar? Any physical quantity with a numerical value. Physical quantity with a number as numerical value which shows the quantity, numerical value with and units. Like here, distance is scalar, right? Why? Um, how can we write the distance? Let's say 2 meters or 30 kilometers or something, or 1.5 kilometers, 1.5 kilometer. All these are distances and they are all scalars, right? They have numerical value and some predefined units, meters or kilometers, something like that, right? We also have area. So 2 kilometer square, so 2 square kilometers, something like that. Here area is a physical quantity and it is uh, it is shown in numerical value and has some predefined units. That is the definition of what scalar. So in the same sense, weight 2 grams or 40 kilograms, 40 kgs. All this is what scalars, right? A numerical value and a predefined unit. Both must be there, right? Mainly what we need a numerical value for a scalar. In a number, we are showing the quantity of the physical quantity. We are showing the quantity of that physical quantity in numericals, right? That is what scalar is. So time is also scalar. 2 seconds or 2 minutes or what 30 hours or 24 hours, 365 days. All these are different numbers, different quantities of time, right? Now vector. What is a vector? A vector is a scalar with direction. So specified direction. If a scalar has a specified direction, then it is called what? Vector. Right. So what are the examples of vector? So there is a quantity called displacement. So displacement is the shortest distance between 2 points. Shortest distance between 2 points is called displacement. And for example, let's say I'm taking a point A, and from point A to point B, someone traveled 2 kilometers. So this is the distance. If so, vector is a scalar with direction. Also, scalar has some numerical value which is called the magnitude. So the same numerical value of a scalar that will be given to vector also. So when it comes to vector, that numerical value is called magnitude, right? And along with the magnitude, vector also has direction. So in this case, if distance is 2 kilometers, then displacement is also 2 kilometers, right? Here what displacement is the shortest distance. Here from point A to point B, the shortest distance is also 2 kilometers. So we take displacement, the magnitude of displacement is 2 kilometers, and the direction of displacement is along the motion of the person or the thing that is traveling. The direction is always along the motion, right? So if I take like this, from point A, someone traveled right towards the west, towards the east for 2 kilometers, and from this point he turned right side and went south, and he went some like this, yes, to another 2 kilometers. He traveled south. He reached point B. Then distance. What is the distance? This path plus this path. So 2 plus 2 equal to what? 4. 4 is the distance. But what is the displacement? Displacement is the shortest distance between the two. Between the shortest distance, possible distance. So here the numerical value of distance is not equal to what? The displacement magnitude. Why? This here it forms a right angle triangle. So by Pythagoras theorem, we can find out the shortest distance from point A to point B. So root over 2 square plus 2 square, 4 plus 4 is root 8. So root 8 is the magnitude of displacement. Right, this is the magnitude of the displacement, and the direction of displacement is along this way, A to B, directly towards B. It's directed towards this path. Right, this is the displacement. So in case of what, circular motion, if I take circular or spinning motion, if uh, there is a ball attached to a string, this string, and I spun it, I revolved it around the center, around my hand, I revolved the ball along the string, and if radius is here, the length of the string is 2 meters, let's say 2 meters, then the radius of this circular path will also be 2. So here the circumference of this circle, what is this? So 2 pi into 2, 2 is the radius, so 2 pi into 2, so that is 4 pi is the, so 2 pi into 2, so 4 pi, so let's say, so 4 pi is the, 4 pi is the circumference. So we can say this is the distance. Distance is the path covered. Path covered, the length of the path covered. Length of the path covered is the distance. So therefore 4 pi is the distance. And now displacement. Here the shortest distance, shortest possible distance is what? From here to here. The start point is here and the end point is also here. So the shortest distance between from one point to that same point will be 0. So the displacement here in the circular motion in a closed loop, simply in a closed loop or circular loop, displacement will be 0. Right. Direction, for the direction it will be, when I take this point, direction will be this side.